Okay, we've talked about the deal streamer elements. Now, let's build our first video analytic pipelines. The first thing you want to do when you open a new terminal is to initialize the deal streamer. So go to opt-intel deal streamer and source the setup DLS environment script under scripts. Next, let's go to samples. You already have the deal streamer samples installed with a package. In order to run anything, you need a model. So let's run the download public model script. Before we do that, you gotta make sure you have the model's path variable set so the script knows where to save the models to. Run the script. It will bring all the models one by one. You can find the models under Models, Public, then the name of the models and the format. This is an IR format, a format that OpenVINO can execute. You can see here the XML and the .bin files. Models are here and we are done. The list of the models could be found here. Feel free to edit the list. And this is the list for the Intel optimized model. Here, you can just edit the list, and I'll run the second script as well to bring the OpenModel models. These models are highly optimized and are totally free to use. Okay, we have few models. Now, get some video files to use as inputs. There are many free video sites all over the internet. Let's start with a simple pipeline you have already seen. GST launch. Here, I'm using a local video file. I decode it, I convert the video to the right format, and I present it to screen. A pretty slow video. The first element I'd like to use is called GVA FPS counter. I'll add it here at the end, and it will print to the screen, not to the video, the actual frames per second this video is being processed. Here, we're getting 12-13 FPS. This is not system limitation. This is how the video was coded. I'll show you if you add another channel. Here, I just copy-paste the same pipeline. Do not put a pipeline sign between them. I'm getting 24 FPS, 12 FPS for each of the channels. And now, let's add the analytics. After the video is decoded, it is not compressed anymore, and we can process it. Deal streamer will hand a frame by frame to the next pipeline. I'll use GVA detect, and I need the location of the model.xml file, which is located right under the models, Intel. I'll use the face detection model in FP16 format. I can, of course, add here more parameters like target device, CPU or GPU or other batch size and more. And we need another deal streamer element, which is called GVA watermark. This element will add the GVA detect results, in this case bounding boxes around the detected object, to the video. And close the pipeline, convert the video, count FPS, present to the screen. And you can see that the faces are well detected and FPS does not drop. A full video analytic application using one line of code. Now, let's add another functionality to the analytics. So far, we've processed the video and detected faces. Now, let's take each of these faces and try to detect the age and the gender of that person. We'll do it using another AI model. This AI model can get faces as the input and output the age and the gender. This is a pipeline we just use. First, we process and decode the video. Second, we are executing face detection using GVA detect. And now we take the result, the output of the face detection, and pipeline them to the age and gender model. It functions like a classification model, so we use GVA classify. You can read all about it in the manual or use GST inspect. GVA watermark is now supposed to add to the video not only the outputs of the face detection model, but also of the age model, basically aggregate all the outputs. The pipeline is running, the video is being processed to the screen, and I'm getting no errors. but I can see the face detection results. Something is wrong. Can you guess what? The two models, the face and the edge detection, work totally different if we use them as a black box and just compare the interfaces. On the left is the face detection model, on the right is the age and gender one. The face detection model is expecting an RGB image at this resolution as the input. The right model is expecting a face 64 by 64 pixels as an input. So we basically have to run it not on the full image, but again and again on each of the faces in the original image. As for outputs, the face detection model outputs a vector, basically 200 potential faces. Each is 7 entries long, with the coordinates of the face, the confidence level, and more. The age and gender model has 2 outputs. This is the first one, a vector of 2, holding the male or female classification, and another one is a number with the estimated age. I guess it is obvious now why we need to explain the DL streamer what each of the models is doing. We can do it using a JSON file we call model.proc, or in the description of the model itself in the IR file, the OpenVINO format, to describe the AI model functionality. So this is how the proc file is built. I'll leave you the link below so you could learn more. It basically looks like a JSON file holding all kinds of parameters, like do you need pre-processing before you execute the model, or some post-processing after. For this model, for example, this is an emotion detection model. You have here the labels description, which could be on all of these 5 potential emotions. Basically, you can tell the DL streamer all about the model functionality. DL streamer can process the proc file to understand the model, but the better option is, if you're using a new model, is to code all this information into the IR file. There is a section in the XML file called model info that can hold all the required information alongside, of course, the neural network description, a little bit more elegant. Please navigate to the samples directory, opt-intel DL streamer samples, go to GStreamer, GST launch, and to the face detection and classification directory. Under model proc, you can find the proc file for our age and gender model. It looks like that, basically describing the model, the name of the output layers, and the labels. This is our face detection model. This is the age and gender classification, and we'll add the path of the model proc JSON file and the rest of the pipeline. And it is working. You can see on the original video the faces, and for each one of them the estimated age and gender. The face detection model is executed on every frame. The age and gender model is executed twice on each frame on each of the faces. You can appreciate how complex it could be and how simple it is to code using the DL streamer. Pretty cool. The only thing I would add here is a queue pipeline. Basically, we have here one long pipeline. Different stages of a pipeline can take longer time to complete, and you do not want them to block the rest of the pipeline. So a queue element basically tells DL streamer, or actually GStreamer, to place a buffer at that point and synchronize all the queues so they will not block each other. That is all. In our case, you will not see much difference. And last for this video, here is a full sample that utilizes 4 models, one after the other. Look at the script for the face detection sample, go to the end. We're basically executing the string pipeline. And pipeline is constructed by a source, which could be several options if you look at the beginning of the file, decoding, and then 4 models, one after the other. The first is face detection model, and the other 3 are classification models. Each one has a path to the model XML and to the model proc file, and a source, a sync element, to display or save the result. Each of the models will run on the device and there are Q elements to synchronize all the model's outputs. You can look at the beginning of the file to see the definition of each of the elements. I think it's nicely built and simple to understand. Just run it. You can see the face detection, age, gender, the emotion, and even landmark pointing to the specific location on the face, all displayed on the original video. Pretty cool. Please try to run it yourself. Please try to run each model on a different device, CPU, GPU, or NPU. Try to change the order of the models in the pipeline. Does it make any difference? We have built our first video analytic application using one line of code. We've used several models in the same pipeline. Try it out, play with it a little, and I'll see you on the next video.